Okay, so today we will continue from yesterday. Yesterday we have seen about the linear regression with just one input feature. And so today we will continue about linear regression, but with multiple input variables or input features. So let me share my screen. Okay, this one. Okay, so yes, we have already done this exercise, so I hope that everyone is okay. So when we talk about linear regression with multiple variables or multiple input features, the difference is not a lot from with just one input feature. The thing is that we have to, in our hypothesis, we have to have more parameters. So if you have two input features, you can see we add one more parameters. So yes, it depends on the number of input features. Usually for linear regression, the number of parameters is equal to the number of input features plus one, right? Yes, we have to have a bias as well. And for other parameters, they are like coefficient of each of the input features. That is why we can write something like this. Okay, this is the general hypothesis of linear regression with any number of input features. All right, the cost functions is still the same. So we do not change anything for the cost function. We still use mean square error rate, no, mean square error for to be our cost function. And the objective is to find like the values of all the parameters in order to minimize this cost function. So we still apply the gradient descent just like before, but this time we have to compute the gradient for all of with respect to all of the parameters. So something like this. Okay. So yes, any question about the hypothesis about cost function and about how we can apply gradient descent? Is it clear for everyone?
លោកគ្រូសុំសួរកន្លែង cost function ទីលោកគ្រូឧទាហរណ៍នៅក្នុងនេះលក្ខណៈថាគេ minimize វាទៅរកតែមួយទៅវាស្មើនឹងទាំងអស់ហ្នឹងមែនលោកគ្រូ
Yes, because you can see that our hypothesis now is composed of these parameters. So if you want to minimize the cost function, you have to find like the values of all the parameters.
The value of...
So the cost is just one single value. But in order to compute the cost, you have to take into account all of the parameters. តនេះកន្លែងហ្នឹង cost របស់យើងកណនីចេញមកអត់មានចេញជា value ច្រើនវាជា scalar value វា value តែមួយទេប៉ុន្តែដើម្បីកណនី cost function ហ្នឹងយើងមាន hypothesis របស់យើងទៅហើយ hypothesis របស់យើងវាត្រូវមាន parameter នៅក្នុងហ្នឹងអញ្ចឹងដើម្បី minimize អា cost ទាំងបានតតែយើងត្រូវ find អា value នៃ parameter ហ្នឹងទៀតអញ្ចឹងពេលដែលយើងប្រើ gradient descent មកគឺយើងនឹងអាចរកឃើញ gradient with respect ទៅកាន់ធៀបជាមួយនឹង parameter មួយហ្នឹងហើយខ្ញុំតោះមកយើងអាច update គ្រប់ parameter ទាំងអស់អញ្ចឹងទៅយើងនឹងចុងក្រោយបំផុតយើងបាន final value នៃ parameter របស់យើងហើយចាហ្នឹងវា it doesn't matter how many parameters as long as you can compute or you can calculate the gradient of the parameter, you can use the gradient in order to update that parameter. Is that your question?
Yeah, for sure.
Okay. Any other questions? Okay, no question. We can continue. So yes, this is the technique that I mentioned yesterday about feature scaling. Because in yesterday exercise, you see that if you apply just one learning rate, like the update for parameter A and parameter B is not are not the same, right? So if our learning rate is too small, like it's small, we can update the value of parameter A just fine. But for parameter B, it is like too slow, right? It will take a lot of iterations in order to for parameter parameter B to arrive at the optimal location. So this is because the parameters are not in the not the parameter the input features. The input features are not on the same scale. Okay, so it is a good idea to apply feature scaling technique for the input features. Let's look at the example here. You can see now we have two input features. So we have x1, which represents the size of the land in meters square, and we have h2, which is a distance. And you can see that according to the examples here, for the size, the smallest value in our data set, it is 90, right? And all of the examples, the values of h1 are in the hundreds, right? And for the distance to the city center for this input feature, you can see that the smallest value can be like 1. So it is in the 10th. So you can see that the range of the two input features are not the same. So when we apply our gradient descent, especially when we define our when we choose the learning rate, it will affect the update, the change of the parameters corresponding to each of the input feature. Okay, so it is a good idea to do the scaling for each input feature so that all of the input features are in the same range or are in the same scale. That is why we will apply feature scaling. So in order to apply feature scaling, we can use this formula. So this is the old input feature. So one of the input features, hj. So we can do something like this. We replace all of the input with this instead. So hj minus mu j. Mu here is the mean. The mean of all the values corresponding to that input features in the example in the data set. And then we will divide by sj. So for sj here, we can use a standard deviation, okay, or just simply max minus min, like the range of the input features. What is the largest value? The difference between the largest value and the smallest value. We can use that as sj as well. We can use standard deviation. You know standard deviation, right? Standard deviation and variance. Just for standard deviation.
ស្គាល់លោកគ្រូប៉ុន្តែខ្ញុំចង់ដឹងអា standard deviation ហ្នឹងគេច្រើនគេប្រើតម្លៃវាជាឲ្យគេលោកគ្រូតម្លៃបញ្ជាក់ជា data គេលោកគ្រូ
Sorry data របៀបម៉េចចង់សួរពី
ខ្ញុំចង់ដឹងថា like ធម្មតាបំមានវាមិនបញ្ជាក់ឲ្យគេជា average value តែ standard deviation ហ្នឹងវា show ឲ្យគេលោកគ្រូវា show ឲ្យគេពីទិន្នន័យរបស់យើង
The definition of a standard deviation, it is the average difference between the data and the mean.
យល់
Này vớiรูปมนต์วิทย์យើងមិនត្រូវយក data point មួយដកជាមួយនឹង min ហើយលើកជា array បន្តមក average ចូលទាំងអស់អាហ្នឹងហើយគឺជា standard deviation បន្តមករឹសទៀតរឹសបាន standard deviation បើសិនជារបស់ហ្នឹងលើកជាបើថាអត់ដាក់រឹសទេអាហ្នឹងវា variance វិញមិនចឹង Okay. So for the lower part of the division, you can use standard deviation, which is like more costly, more expensive to compute. Or you can just simply use the range, the difference between the maximum value minus the minimum values. M is the number of examples in our data set. So the mean and the standard deviation here is the mean and the standard deviation of the data in our training set. Let's look at the previous example, exercise 4.1. You can see that in our data set, the features here, we have only one features, but we can also apply feature scaling. So you can see that we have 10 examples. So here M is equal to 10. So we can convert this one, if we can apply feature scaling. So for this feature, we can find the mean. So you can sum everything together and divide by M. So you will find the mean. And then you can replace each of the value here with the formula that I have shown you before. So for example, like we find the mean, our mean is mu, right? Mu. And then, for example, like here, the value is 90. So we have to, after applying feature scaling, so 90 will become 90 minus mu divided by the standard deviation, or we can just divide it by the minimum, no, the maximum minus the minimum. So 710 minus 90. Okay, yeah. And if you do like this, all of the features, even though it for this example we have only one, for this exercise we have only one feature, but you will see that the range of our input features now will be the center will be 0, right? So the center is 0, and it is close to 0, the value. It is very small, close to 0, and the middle. Yes, and I mean that after applying the feature scaling here, the mean will be 0. The mean of the new input features will be 0. Right? And the value will, all of the feature, the value will be close to 0. So if we have multiple input features, we can apply the feature scaling for each of the input feature, and so after the feature scaling, everything will be in the same scale. And you can use just one learning rate, and it will work for all of the parameters. Yeah. So I think that is it for feature scaling. So no problem for feature scaling.
Lúc cụ chụp bùa feature scaling á việc phở ban tờ mà bạn mùi variable là này lúc việc ai apply multiple variable này.
The feature scaling, it is used for multi-variable linear regression, or not just linear regression, any machine learning technique. that that for the input is consist of a lot of features. We can apply the feature scaling for each of the feature តែ feature scaling ហ្នឹងអាហ្នឹងគឺសម្រាប់ប្រើសម្រាប់ពេលដែលយើងមាន input variable ច្រើនហ្នឹងហើយហើយជាពិសេសពេលដែល input variable របស់យើងនៅ range ខុសៗគ្នាយើង apply feature scaling មកវា range វានៅដូចគ្នា Okay. Okay, so if there's no more question, we can continue. Yes, so we have seen linear regression. So now let's talk about polynomial regression. Okay. So you can see this is a hypothesis of linear regression with one input. So if we draw it on the graph, it is a line like this because it is linear, right? However, we can do something like this. We can use this hypothesis instead, and you can see that we still have only one input feature. It is still x, but now we have added one more term, x squared, and we will use another parameters for that term. And we can say that now the equation is polynomial. It is not linear anymore because you can see that our variable, the order, the degree of the variable is now 2. Okay, yeah. And if we draw this, the curve represented by this equation, you can see that it is not a line anymore. It is a curve like this. And for this data, you can see that according to the structure of the data, it is not really straight like a line. It is more like a curve. So it might be a good idea to use this equation as our hypothesis instead of just the linear one. Okay, so how can you train your, so if we use this polynomial as our hypothesis, how can we compute the gradient in order to be used in our gradient descent algorithm? Because if we use this equation, you can see that the derivative, it will be different, right? There is a workaround. So instead of doing this, we can just create new variables. So now we have two variables. X1 is equal to just x, and x2 is equal to x squared, right? So even though we have only one input in our data, we can convert it into two input features. So now we can have this as our hypothesis instead. And you can see that this is still considered as a linear regression, right? But actually, when we draw the line, because we use only one input, it is not linear. It will be like polynomial instead. But we can convert it to this hypothesis so that we can still apply the same computation as before in order to compute the gradient to minimize our cost function. Okay, is it all right for this point? And here are some examples of polynomial equation that we can use as our hypothesis. We can increase the order of x of our variable, or you can also do something like square root as well. So yes, the higher the order of the polynomial, the more flexible the curve. If it is very high in order, so our curve can be something like this. Okay, yeah. Any question? Okay, now we have our exercise. If you have no question, we can go straight to the exercise. So this time we have one data set, and now a CSV file is provided for this data set. So you can download it from Microsoft Teams. I have uploaded this file already. So in the file, you will see there are 3 columns. So the first 2 columns are our 2 input features. The first column is the land area, and the second column is the distance to city center. And the final column, the third column, is the label. It is a Y, the Y, the output. So let's try to build a linear regression to fit this data. Okay, so I can go into Google Colab.
លោកគ្រូនៅខ្ញុំ download មើលទៅនៅក្នុងនោះវាមាន3 column អញ្ចឹងយើងអាចយើងកំណត់ធ្វើម៉េចដើម្បីឲ្យយើងអាចដឹងថាមួយណាជា x មួយណាជា y លោកគ្រូ
ខ្ញុំមានដាក់ label ខាងលើវាទៅដាក់ header វាខាងលើហ្នឹងមិនអញ្ចឹង
header នេះលោកគ្រូដាក់ land area ហើយ distance to city and price
ហ្នឹងហើយអញ្ចឹងយើងចង់ predict price អញ្ចឹង price របស់យើងហ្នឹងឯងគឺជា output តែអាពីរខាងដើមហ្នឹងគឺជា input របស់យើង
price វាជា output អត់បានលោកគ្រូចុ
ះលោកគ្រូយើងមាន input 2អញ្ចឹងយើងដឹងអាណា XO ណា XD ទៅលោកគ្រូ
អាហ្នឹងអាស្រ័យលើយើងយកអាណា X1 អាណា X2 ក៏បានដែរវាអត់ជា different អីទេអាហ្នឹងពីព្រោះអាហ្នឹងគេថា order នៃ input feature យកអត់សំខាន់ទេអញ្ចឹងយើងយកអាណា X1 អាណា X2 ក៏បាន Okay, so let me so I will also try to introduce you to PyTorch for this one. Let's where is my coding here? Okay, so this is okay, so please wait a bit. Okay, NLP. Right here. Create one more Google Colab. Okay, let me share my screen. I forgot to share my screen. Okay, so let's call it ch4 4.2, right? All right. Okay, so in Google Colab, you can upload the data, upload any file to Google Colab. So you can do it just by clicking here. Yeah, I will. So here you can see this is the local storage for our Google Colab. So here I can create one more folder. Let's call it like my data. And then I will upload to this the CSV file. P data, okay, 4.2. Okay, you can see it is now uploaded to this folder, and we will try to extract the data from this CSV file. So you can consider it as just like a normal text file. You can use Python code in order to read from this text file. Because a CSV, it is just like a text file, and the data is separated by commas, right? So I can just copy the code from here because I have already written some code in order to extract the data. So you can see here, I create one function called read from CSV, and we put in the path to our CSV file. And here you can see that we can use open in Python in order to open a text file. And here it means that the all mode it is just for read, right? For reading, for read the data from the file. And we can use something like read lines in order to extract all the lines in the CSV file. And you can see here I use pop 0. So we will remove the first line because the first line is just the header, right? So we do not need the header. That is why we will remove the first line. And you can see here I create three arrays in Python. And I use one loop in order to get the data. So you can see for each line we have all of the data in each line, right? So we have the first value is corresponding to input feature number 1, input feature number 2, and the output. Okay? So we can just do something like split, and the delimiter is the comma. So we will get 3 different values, and we have our h1, h2, and y here. And then we can just add it to our list. So after the loop, we will have 3 different arrays. One for h1, one for h2, and the last one is for our label. Okay, so here we can just change the name to our CSV file, so data 4.2.csv, and here we will obtain the 3 arrays. So let's try to print out, let's say h1, h2, and h3. I don't know why. Okay, you see.
upload file upload lại nè
នេះអ្នកយើងឃើញកន្លែងនេះ folder ហ្នឹងឯងយើងចុចកន្លែងហ្នឹងមកឃើញដែរបងប្អូនកន្លែង upload ហ្នឹង
ឃើញហើយឃើញ
តែយើង right click មក upload ប៉ុន្តែទៅថាបើសិនជាយើងចង់បង្កើត folder មានក្នុង folder ទៅមួយទៀតដើម្បីស្រួល organize ទិន្នន័យរបស់យើង right click ហើយបង្កើត folder សិនមកហើយ right click លើ folder ហ្នឹងហើយចាំ upload ហ្នឹងវា upload ចូលក្នុង folder ហ្នឹងហើយដល់ពេលយើងដាក់នៅក្នុង code របស់យើងទៅសេវាអាហ្នឹងអានេះដូចជា root folder អញ្ចឹងហើយបន្តមកបើសិនជាមាន folder ក្នុងហ្នឹងទេយើងដាក់បន្តគ្នាអញ្ចឹងមកជាដូច path របស់យើងអញ្ចឹង path ទៅកាន់ file មួយហ្នឹង Okay, yeah. So we have this code. Now we can read all the data from the CSV file. And next is to create our hypothesis, right? So now I will use NumPy instead of just like a single value for our parameters. So let's import NumPy. Okay. And you see that our okay, let me okay, so we have 4.2 here. Okay, and we can look here at our hypothesis. So you can see we will use this one instead. Right?
library យើងប្រើហ្នឹងគឺប្រើជាប្រើ NumPy និង PyTorch.
Yes, we will use PyTorch. If you use Google Colab, you don't have to install anything. In Google Colab, we already have NumPy and PyTorch. Okay, so for our hypothesis, we would like something like this, right? Yeah. So actually, we can use matrix multiplication in order to obtain this instead of just computing multiplying one value at a time. Okay. So for x, right? For x, we can do something like equal to or we can something like this. Okay, x0, x1, and x2. Okay, something a vector, or we can say that it is a matrix. What is the dimension of this matrix? It is 1/3, right? This matrix, it is 1/3. And then for the parameters, we can also create a matrix. So I just write theta. It is equal to theta 0, theta 1, and theta 2. Right? And so this is what? This is 3/1. Right? Right? This is 3/1. So we can write something like do matrix multiplication, something like x multiplied by theta. So it is equal to what? What is the dimension of this matrix multiplication? What is the output matrix? The first matrix is 1/3, and the second matrix is 3/1. And when we do the multiplication, what is the output? What is the dimension of the output matrix?អាហ្នឹងរបៀបគុណ matrix យើងរៀនតាំងពីថ្នាក់ high school. Vậy mình 1 គុណ 3 បន្តមកទៀតមាន matrix មួយទៀត 3 គុណ 1 ដល់គុណគ្នាទៅចេញអីគេ?
Lệch bạn ấyលោកគ្រូ
ធ្វើម៉េចដើម្បីគុណ matrix 2ចូលគ្នាបាន?
ដូចជាយក x0 គុណ1 1ហ្នឹងគ្រូហើយ
អត់តែយើងមាន matrix A B យកថា matrix A គឺ dimension របស់វាគឺ mn មិនចឹងដើម្បីឲ្យគុណជាមួយនឹង matrix B បានតើ matrix B នេះមិន n ហើយតើតានេះ the second dimension of the first matrix is identical or is the same as the first dimension of the second matrix, and the result is matrix C, and the dimension is what is m by k, right? So for this we have x, the dimension is 1 by 3, and theta, the dimension is 3 by 1. So when we do the matrix multiplication, the result will be 1 by 1, right? So it is just one value. And how do you compute the matrix multiplication for this case? It will be something like this, right? It will be exactly like this. So each element of the first matrix multiplied by corresponding element in the second matrix, and then we do the sum. So it is exactly like this. So here theta 0 multiplied by h0. And we know that h0 here is 1, right? So instead of using this formula or this expression, we will use matrix multiplication instead, because it is much faster to use matrix multiplication. Okay, yeah. So what is our hypothesis now? So for our hypothesis now, it will be something like we will input into the hypothesis x, and then theta. Okay, so theta here is our parameters. Probably I can just call it T8, which is short for theta. Okay, so let's try to put a comment here to state the dimension so that you will be not confused later. So for x, it is a numpy array, and the dimension is what? 1 by 3, right? And for parameter theta, it is numpy array as well, and the dimension is 3 by 1. Okay, yeah. And we can just return the matrix multiplication of this one. So it will be something like in NumPy we have a function called matmul, I think. Yes, here. Matrix multiplication. So we will multiply x with th. Okay, so this is our hypothesis now. All right, and what about our cost function? Actually, it is xi, right? Only one example, so maybe I can input xi as well. Yeah. Actually, for this one, we can also try to compute all of the examples at once as well. You can see that if we do something like this, we compute one example at a time, right? And during training, we have to find the cost of all the examples in our data set. So it is maybe a good idea to compute all of the output predicted by our hypothesis or our model at once, right? At the same time. So here, instead of just xi, I will use x instead. And the dimension is not 1 by 3, it is now m by 3, right? So we would like our x to be like to represent the whole data set. So you can see m rows. So each row represents each example. And we have 3 columns because we have 3 input features. Next line. So here we will use X. And what is the dimension of the output? What is the dimension of the output? It will be numpy array. How many by how many?
1 by 1.
No. This time we do not input only just one example. We input the whole data set. So we have m examples. So you can see that
m គុណ 1.
Yes, m by 1, right? Okay. So what does it mean m by 1? It means that we have only one value, but m rows. So it is so they are the outputs of all the of all the examples, and the outputs predicted by our hypothesis here. Okay. Yeah. And in order to compute the cost function, we can also input x and then the parameters, or probably we can just input z, which is z is the output predicted from our hypothesis, right? And then we have y, so we have to compare z and y. Okay, so for here, what can we do? We can write something like what is the cost function again? You see, okay. So we have z minus y, and then square, right? So we can use numpy square. This one, and then sum. So maybe np dot sum. And then divided by m, right? So m is the first dimension of z, right? M is the first dimension of z, so we can divide it by z. Shape here is in NumPy, the property shape will produce will return the dimension. Okay? So if we have 2 dimensions, it will return us an array. Like the first value is the corresponding to the first dimension, and the second value corresponding to the second dimension. Right? So we would like to get m here, so we can write something like shape 0. Yeah, because the index start from 0, right? So this is 0, this is 1. Okay, so just like this, we can compute the cost function. Then for gradient, what can we do in order to compute the gradient? You can see here, this is how we can compute the gradient. So this one is z, right? This one is z. Z minus y multiplied by xj. So probably I will try to introduce you PyTorch instead, because here you can see that in order to compute the gradient, we have to do a lot of computation. We have to find the derivatives of our cost function with respect to each of the parameters. That is why we have to use PyTorch, because PyTorch, this library will try to compute the gradient for us. We do not have to explicitly compute the gradient by ourselves. Okay. So yes, so here you will see this one. We will compute the hypothesis and the cost function by using NumPy, right? So now let me create one more block, and we will use PyTorch instead. Okay, in order to use PyTorch, we have to import Torch. So this is our PyTorch. All right, and then we can create our. So in PyTorch, we do not use array anymore. We use another object called tensor. យើងដែរលើ tensor មាន concept ខ្លះអំពី do you have any idea about tensor? What is a tensor? ធ្លាប់ឮពាក្យហ្នឹងឯងធ្លាប់យល់ពីអត្ថន័យនៃពាក្យថា tensor ហ្នឹងឯង
ដូច tensor flow.
Yes, TensorFlow. In TensorFlow, yeah, the name TensorFlow because they use tensor as well. Okay, so let me show you first about the definition of tensor. So in Python in general, we have a Python array, right? Python array, we can write something like A is equal to open and close a square bracket. So it is to initialize an empty array in Python, right? And then we have a NumPy array. So for NumPy array, it is not a Python array anymore. So it is an object, right? It is an object that inside that object, we have an array inside. And the NumPy library, we can use this object in order to do a lot of things, right? And we can consider this object to be just like a matrix or a multi-dimensional array. Yeah. And then we have one more thing, PyTorch tensor. Okay. For PyTorch tensor, it is an object as well. And inside it, we have an array as well. Okay. But we have a lot more. We have a lot more properties inside a tensor. Especially one is called a property is called grad. Okay. Which is short for gradient. So for each tensor, it contains one property to store the gradient of that tensor. Okay, and here you will see soon that this one is very useful when we do the back propagation, or when we try to find the gradient, or we try to apply gradient descent. Okay, yeah. So in PyTorch, when we try to compute something, it will create a graph, and we call it a dynamic graph. Okay, so let's say that I have x. X here is a tensor. And I also have A, which is a tensor as well. Right? And then B as well. B is also a tensor. So I have three tensors, X, A, and B. And then I have something like Z, which is equal to A multiplied by X plus B. Okay, I have something like this. So you can see that this is a computation. So in PyTorch, because this one is a tensor, this one is a tensor, and if one of the variables in the expression is a tensor, it will create a graph, a dynamic graph. right? So it means that here z will be the root, and in order to compute z, we have something like here. So we have something like something like this, right? Plus, and then here b, and here multiply, and here a, and here x, right? So it will create something like this to represent this computation, to represent this expression. So you can see that in order to compute z, we have to use a, x, and b, right? Yeah. And in PyTorch, we can do something like when we have z, we can write something like z dot backward, because z is now a tensor. It is computed from tensor, so it is also a tensor. So we can call one method of a tensor is called backward. Okay, backward here represents back propagation, which is the term to use when we apply gradient descent, when we try to compute the gradient, when we try to find the derivatives, right? It is backward. So when z is backward, it will look at the computational graph. Okay, this is a dynamic. Also, we can call it a computational graph. Computational graph. Okay, we will look at this dynamic computational graph to see what are the tensors that we use in order to compute them. So this we have a, x, and b, right? So it will try to compute the gradient for all the tensors. So when we call z dot backward, it will try to compute the gradient with itself as well. So the derivative of z with respect to z itself, and then for with respect to all of the tensors computing that we use to compute z. So here we will obtain derivative of z with respect to b, derivative of z with respect to x, and derivative of z with respect to a. Okay, and where are all of these values of the value of these derivatives stored? It's stored in the gradient property of each of the tensors here. Okay, so after we call backward, if we write something like a dot grad, okay, so it will return this one, the derivative of z with respect to a. So you see that in PyTorch, it will calculate this gradient. So this is the gradient, right? This is the gradient of z with respect to a. So you can see that we do not have to program how to compute the gradient, how to do the derivative by ourselves. PyTorch will do it. Will do it for us. Okay. តនេះកន្លែងហ្នឹងអរគុណ So I can give a very short example, like for example, a is equal to torch.tensor. So this is how we can create tensor in PyTorch. Okay? Here the torch is our library, and then we have a function called tensor, and then we can put any value, and we will convert that value into a tensor. It can be a single value, or it can be an array. It can be a matrix, or it can be a multi-dimensional array. Okay, so let's something like 10. And then b is equal to torch.tensor 20. And then x is equal to torch.tensor like 1, for example. And then we can write something like z is equal to a multiplied by x plus b. We can use the Python operator with tensors. PyTorch will know that it will be a multiplication of a tensor, right? So this expression will produce another tensor here. Okay? For example, if we try to print out z, You see, it will print out 30, and it is a tensor. Okay, yeah. And let's try to write something like z dot backward. So here we do the derivatives, we do the back propagation, right? So let's try to run it. I think it will produce an error. See, why do we produce an error? Because by default, PyTorch does not keep track of the gradient, right? Like here, by default, all tensors do not keep track of the gradient. We have to specify that like which tensor that we need to keep track of the gradient, right? So in this tensor here, we have one more property called require grade. It means that it requires to store the gradient in this tensor, and by default, this property, this attribute is equal to false. So the tensor does not store gradient, does not keep track of the gradient, right? So yes, in order to do the backward, it means that we have to find the derivative of something, right? So it means that here some of the tensors should require grade, so that we can do the backward here. And usually, let's look at our lesson about linear regression. So what are the tensors? What are the things that require grades that we need to keep track of the gradients? Let's say that it is our hypothesis for linear regression. X is equal to a x plus b. Okay. So we have three values here, three objects here: a, x, and b. So which ones are the ones that need to keep track of the gradients? X, for x, does it require to keep track of the gradient for x? តន់សំណួរខ្ញុំទេបងប្អូន
អត់ស្ទាន់ព្រោះអា keep track នេះchẳngមានន័យថាម៉េចទេគ្រូ
បានន័យថាជាទូទៅពេលដែលយើងបង្កើត tensor គឺវាអត់ខ្វល់រឿង gradient ហ្នឹងទេព្រោះដោយសារនេះ property require grade នេះ by default គឺវា false បានន័យថាដូចពេលដែលយើងហៅ backward នេះវាកណនា gradient ហ្នឹងសម្រាប់តែ tensor ណាដែល require grade នេះស្មើ true ទេព្រោះតោះតែយើង specify ថា tensor ហ្នឹងត្រូវការ gradient អាហ្នឹងបានពេលដែលយើង backward មកវាទៅកណនា gradient ឲ្យបានន័យថា by default យកអត់ទៅកណនា gradient គ្រប់ tensor ទេយើងកណនាតែ tensor ណាដែល require grade ទេតោះនេះហ្នឹងហើយហេតុអីបានគេធ្វើអញ្ចឹងដើម្បីកុំឲ្យវា computational expensive ពេកពីព្រោះទីទៀតយើងឃើញពេលដែលយើងប្រើ PyTorch ចូលទៅដល់ deep learning ចូលទៅដល់ neural network អីទៅវាមិនមែនមានតែ parameter 2 3អញ្ចឹង parameter ហើយនឹងអាញាប់យើងឡើងរាប់លានអញ្ចឹងបានន័យថាដើម្បីឲ្យវា optimize អញ្ចឹងគេត្រូវមាន mechanism ហ្នឹងណាចឹងឥឡូវបកមក example យើងវិញនិយាយថាឥឡូវខ្ញុំមាន hypothesis ហ្នឹងមាន3ហ្នឹងហើយយក3ហ្នឹងជា tensor ទាំងអស់ a x b ចឹងសួរថាតើមួយណាដែលគួរតែ require grade ថាមួយណាដែលមិនបាច់ require grade សួរថាយើង require grade ហ្នឹងដើម្បីយើងកណនា gradient ធៀបជាមួយនឹងអាហ្នឹងត្រូវទេសួរថាឥឡូវក្នុងចំណោម3នេះយើងត្រូវការកណនា gradient ធៀបជាមួយនឹងណាខ្លះកណនា derivative ធៀបជាមួយនឹងណាខ្លះយើងនៅចាំយើងមិនត្រូវកណនា cost function ត្រូវទេហើយប្រកាសជាយើងត្រូវកណនា cost function ហ្នឹងហើយយើងត្រូវកណនា derivative cost function ហ្នឹងធៀបជាមួយនឹងអីគេយើងនៅចាំទេ about the gradient descent algorithm we compute the gradient of the cost function with respect to what
Nick gradient AB
respect to what? With respect to A and B. What are A and B?
A B ហ្នឹងគឺកន្លែងដែលយើង input.
No, the input is X. Here's our hypothesis. X is the input. X is the land area here.
អញ្ចឹងA and B ជា initialize.
How do we call it? A and B. And in the multi-variable linear regression, we do not use A, B anymore. We use theta, right? So what are the thetas here? Nó hai thầy chứ. Theta này hai thầy. Làm là so P. They are our parameters, right? They are the values that we would like to know. Nó chăm á ta pia mà sao mình mà. Nè, dương mình trong ban bậc ca chia sẻ cao và toàn này mình chẳng. Làm bây dương từ fit chỉ một data này. Hay làm bây giờ sẽ chia sẻ cao và toàn bát nhưng mà thấy cao parameter P thì A hay là B. Dương thờ đăng thả năng của mát bằng dương ai bậc ca chia sẻ cao và toàn ban mình chẳng. Đó chả A hay là B đấy cứ chỉ parameter bây giờ. Có đấy chẳng. Chẳng làm bây cạnh rõ cả năng bán nhưng mình thử bậc ca cost function muối. Hay nhưng mình thử tới update parameter nữa. Cho làm bây update bán toàn thì dương cạnh này gradient thiếp chỉ môi năng parameter nữa. Chẳng hạn bạn ở trong gradient descent vào những cơ những cạnh này gradient thiếp chỉ môi năng group parameter nữa. Đó đấy, này. Thì là lớp bom vào mình. Bom mà đo cái lại PyTorch bây giờ mấy. So this is our hypothesis. So A and B are our parameters. So now, which tensors that we need to keep track of the gradient? X. Do we need to keep track of the gradient for X?
No.
No. A.
Maybe I'm not sure that, but maybe yes.
Yes. We have to keep track for A and B because they are our parameters, right? We would like to find the gradient with respect to A and also with respect to B. So we should keep track of the gradient for A and B, right? So in our code here, we can write something like, here. In order to do the backward, we have to, we can write here like A dot require, so the requires grade, it has S as well, okay? So require grades equal true. So here we turn on the flag require grade for tensor A, and for B as well. Okay, yeah. So now if you try to print A, print B, and then print X as well. Okay. Yes, one more condition for the tensors to be able to turn on the required grades. It has to have the type. We have to specify the type to be a floating point number as well, right? So here Python is a high-level language, right? So we don't have to specify the type of a variable in Python, but in PyTorch, it is a good practice to specify the type of our data. And in order to turn on the required grade flag or for the tensor to keep track of the gradient, the tensor has to have a type of floating point number. Okay, so yes, when you create your tensor, you can also specify in this argument d type, data type, equal to torch float. Okay, you can use also you can also specify the size of the float. Yes, and usually we can use a float 32. We can use 4 bytes in order to represent a floating point number. Okay, so something like this. So now a is a 10 now is a floating point number. Okay, and the same thing because we want to turn on the required grades flag for B as well. So we kind of have to specify the type of B as well. Okay. Okay. So now let's try to run it again. You see, it now works, and you will see that you see when you print it out, A is a tensor. The value is 10, and you can see that it will print out that this tensor require grades. Require grade is equal to true. If it does not require grade, you can see that, for example, x we do not specify that it requires grade. So when we print it out, it is the value 1 without any mentioning of the gradients. What about z? Last time when we do when we did not turn on the required grade flag for A and B yet, you see that it just print out tensor 30, right? One more thing in PyTorch, if one of the tensors here require grades, so the tensor that we use them to compute, like we use A, B in order to compute Z. So Z will be a tensor whose required grade is true automatically. តនេះកន្លែងហ្នឹងខ្ញុំនិយាយខ្មែរម្ដងទៀតអញ្ចឹងយើងឃើញថាកន្លែងនេះ A ហើយនិង B យើង require grade វាអញ្ចឹងខ្ញុំអាចអាណាដែល require grade for the required grade I will sorry I circle in red so we require grade so this one requires grade, this one requires grades. X does not require grades, but you can see that Z is computed from A and B. Even though with just A, like if at least one of the tensor that we use to compute Z requires grade, Z will require grade as well automatically. We do not have to explicitly turn on or manually turn on the required grades for Z. The required grades for Z will be turned on automatically. តនេះកន្លែងហ្នឹងអញ្ចឹងហើយកន្លែងនេះក្នុង example យើងមុនដំបូងពេលដែលយើងអត់តបានដាក់ require grade នៃ A ហើយនិង B នេះស្មើ true នៅចាំទេតែឥឡូវខ្ញុំបិទនេះអូខេហើយខ្ញុំសាកrun ម្ដងទៀតឃើញទេអត់មានអីទាំងអស់ Z យើងក៏ជា tensor ធម្មតាដែរដល់ពេលខ្ញុំបើកនេះតែបើកតែមួយទេក៏ដោយណាអូខេបើ Z ឥឡូវ require grade ដែរដោយសារ Z ហ្នឹងគឺ compute ចេញមកពី tensor ដែល require grade. Okay, yeah. So now we can continue. So now we can write something like Z dot backward. And then we can do what? We can so now it is equivalent to we do the derivatives of Z with respect to A and with respect to B. So we can print A dot grad and B dot grad. We will see the value. So is it correct? Okay. So let's try to run again. You will see that we will see the value of the gradient of A and B. Okay, yeah. Why is it 1 here? Why is it equal to 1? យើងទាំងអស់គ្នាមិនបាន grade ក្រោយពីយើង derivate z ធៀបជាមួយនឹង a ហើយមិនបាន gradient វាស្មើ1 Hmm? So our expression is like this, right? Z is equal to A plus B. When we try to do the partial derivative of Z with respect to A, it is equal to what?
X.
Yes, it is equal to X, right? With respect to B, equal to
1.
yes, 1, right? You can see that is why the gradient of B is equal to 1. But why the gradient of A is equal to 1? Because we can see in this example, X is equal to 1, right? So if you change the value here like 2, you will see that the gradient of A is equal to 2 instead. Okay អញ្ចឹងតនេះបងប្អូនកន្លែងហ្នឹងអញ្ចឹង PyTorch ឃើញវាស្រួលកន្លែងហ្នឹងគ្រាន់តែថាយើងអត់ចាំបាច់ទៅគិតទៅលើអាការធ្វើ derivative ហ្នឹងទេគឺវាធ្វើ derivative ឲ្យយើង automatically. Okay, so now let's try to apply PyTorch to our exercise. I will create one more block here. So yes, we have I can import torch here. And then what? We can create our tensor first, right? So we have okay, so we have to create our tensor X. Okay, so probably we can write like th1 is equal to torch dot tensor x1, and the type is equal to torch dot float 32. th2 the same thing is equal to torch dot tensor x2, the type is equal to torch dot float 32. And y is equal to torch dot tensor y. The type is equal to torch dot float 32 as well. Okay. So everything will be of type floating point, of type float. All right. We have h1, h2 from this. And we would like our tensor to have this dimension, right? M by 3. So we can do the concatenation. So let's say that Tx is equal to torch dot concat, okay, and okay, here we can write something like x1 and x2 and specify the dimension. So dim is equal to 1. Okay, let's try to print out the x. So I will try to print out tx1 and tx2, or maybe just tx1. Okay, so here is our th1. You see, it is now a tensor. As I mentioned before, we can input into the function tensor here a single value or an array, right? So you can see that h1 is an array, so we can pass it to this function and it will create a tensor which is an array as well. Okay. In PyTorch, we can also return the dimension of the array. We can print out something like th1.size. Okay, and size is a function. So this function will return the dimension of this tensor. So let's try to run it again. You will see that now it is 30. Okay, yeah. But actually, we would like to for it to have like 2 dimensions, so that we can do the concatenation later. So in PyTorch, we can do something like reshape as well. Or maybe I can write something like tx1 is equal to tx1 dot reshape. Okay, we have to reshape it into something like 3. No, m by 3, right? Okay, and m here is the length of x1. Oh, no, not m by 3, m by 1, right? Okay, yeah. So let's try to print out again. You see, here we see only like 1-dimensional 30, and when we reshape it, sorry, when we reshape it like this, when we print it out again, you will see that it is now 30 by 1, and now it has 2 dimensions. Okay, yeah, and we can do the same thing for input feature number 2. So I will write in the same line. So reshape m by 1 as well. And here I can do the concatenation. And let's try to print out the shape of tx, or the size of tx. What is it? I think we don't have to have a list like h1, h2 like this.
th1 ấy là cô.
Yes, th1, sorry. You have to input the tensor, right? Yeah, I think we have to put in an array just like before. Like this. Okay, now it's working. Okay. Okay, so now it is 30 by 2 because we concatenate together the first input feature and the second input features. Toàn ấy là toàn đấy là concatenation đó.
Toàn khổ.
Này, của ấy bên tổ bốc cho mình thử miền là x1 vào dưỡng thì x1 vào dưỡng cứ chỉ tensor thế đại miền âm chuột đấy hay là mua chuột trổ thế đại miền vào là chuột miền chẳng máu hay đọc là for th2 it is the same thing m rows and 1 column, right? So we have to concatenate together so it becomes tx, right? So we have 2 columns and rows the same. And you can see that this is m by 1, right? M by 1. This is m by 1. And this is m by 2. You can see that for the function concatenation here, we have to specify the dimension that we want to do the concatenation. And I specify here dim is equal to 1, dimension 1. And why 1? Because here this is dimension 0 and this is dimension 1. We want to specify this dimension. Okay, you see 1 plus 1 is equal to 2. So what happens if we do something like concatenate and then dimension is equal to 0 instead? What is the dimension of the output from this concatenation function?
Nó sẽ bạn này là khu tên môn nó là khu đã dimension nó bị chênh trở lại 20 mà ở miềnដូចជាវាមួយlà bây giờដាក់0nhưng mà haiជាវាបូកចូលគ្នា60ហ្នឹងដឹងលោកគ្រូ
ហ្នឹងហើយបានន័យថាបើយើងដាក់លេខ0គឺវា concatenate នេះអំនេះវិញចុះវាចេញទៅគេ 2m ហើយ1ដដែលវាដាក់បន្តគ្នាចេះវិញវាដាក់នេះបន្តទៅចេះវិញតោះណាចាហ្នឹងវាអាស្រ័យទៅលើតែយើងចង់ concatenate matrix ហ្នឹងរបៀបម៉េចណាយើងត្រូវ specify dimension ហ្នឹងទៀត Okay, yeah. So now we have tx, but we forget one thing, right? We have to have also x0. Remember x0 here, which is equal to 1, right? So it means that we have to have like the first column of our tx. The first column here should be something like here we have this, and we should have the first column should be all 1, right? And the second column from here, which is x1, and the third column h2, right? So this is x0. So what we can do is that we can try something like I will concatenate here. I will, let's say th0 is equal to here we have a function called torch.zeros. No, this is we want to have all 1, right? So we have one more function called ones, and then we can just specify the dimension. So it should be m by 1, right? And then we can include it here in the concatenation. So th0 as well. When we try to run again, you will see now th, the size is 30 by 3.
លោកគ្រូសុំសួរកន្លែងdim ស្មើ1ទីលោកគ្រូឧទាហរណ៍ដោយសារតែ matrix ហ្នឹងមើលទៅដូចជាយើងឃើញវាតាមួយ column អីចឹងលោកគ្រូតែឧទាហរណ៍បើយើងដាក់ dim ស្មើ2អញ្ចឹងវាធ្វើមិនវិញលោកគ្រូ
Error because we have only 2 dimensions, so 0 and 1.
បានលោកគ្រូអញ្ចឹងអាហ្នឹងវា depend ទៅលើ
depend ទៅលើនេះអាន input យើងហើយយើងគ្រប់ tensor ដែលយើងដាក់ចូលក្នុង list នេះដើម្បីយកមក concatenate ហ្នឹងគឺវាមានតែ2ត្រូវ dimension ត្រូវដូចគ្នាហើយយើងត្រូវ specify ថាតើយើង concatenate តាម dimension មួយណា
បាទលោកគ្រូអរគុណលោកគ្រូ
So now we have our input tx. We would like to have our parameters as well, right? Theta. So we can create our theta. So here I can write something like T8 is equal to torch.tensor. What can we do here?
Đangដូចជាdata ដូចជា parameter គ្រូអញ្ចឹងយើងអាច set តម្លៃវា
Yes, so we should initialize the value of the parameters, right? Because in our gradient descent algorithm, first we have to initialize any values to our parameters. So let's for it to be simple, we can just initialize everything to 0, right? So instead of using torch dot tensor, I will use torch dot zeros instead. And then I can just specify the dimension, which is 3 by 1, right? We have 3 parameters, theta 0, theta 1, and theta 2. So it is 3 by 1. And here I can specify the type is equal to torch.float as well. And because the T8 is our parameters, we have to change the required to true, right? All right. So now let's try to find the cost. So cost is equal to, what is the formula for our cost here? So first we have to compute x of x, right? So this is our z, right? So let's write something like tz because it is a tensor as well. So it is equal to torch dot. Yes, we have this function. Yes, អញ្ចឹងពួកយើងប្រយ័ត្នច្រឡំរវាង PyTorch ហើយនិង NumPy វាមាន equivalent yes between NumPy and PyTorch we have there are like corresponding or equivalent functions. Like in order to do matrix multiplication, in NumPy we use a function called matmul, right? But in PyTorch it is just mm. អញ្ចឹងយើងប្រយ័ត្នច្រឡំផងហ្នឹងណាពេលដែលយើងប្រើ NumPy ឬមួយក៏ពេលដែលយើងប្រើ PyTorch ជួនកាល function ហ្នឹងដូចគ្នាជួនកាល function ហ្នឹងទៅសេខុសគ្នាទៀតណាអញ្ចឹង yes you should be careful about this. So we multiply two matrices Tx and T8, right? Okay, yeah. So I will put the comment here to specify the dimension. So here it is a tensor. What is the dimension of Tz? Mình là cái đó. Tz dimension វាស្មើប្រមាណ
ខ្ញុំគិតមើលទៅ
We can look at Tx, yes. Tx. So what is the dimension of Tx?
30 គុណ 3
m by 3, right?
Right.
And what about Th?
Th 3 by 1.
3 by 1. So Tz is Th multiplied with Th. So the dimension is
m1.
M by 1, right?
by 1.
Yes. Now we have Tz, so we can compute the cost. So we can just do something like Tz minus Ty, right? Actually, we have to look at Ty as well. We haven't created, so here is Ty, right? So let's try to print out what is the dimension of Ty. I think it is one-dimensional. Okay, one-dimensional. And you have to be careful as well. Like in PyTorch, we have something like tensor and tensor like 30 by 1 and tensor 1 by 30. You see? So it is composed of 30 elements, but they are different. This is just one-dimensional. This one two-dimensional, which means that it has 30 rows and 1 column. And this one, it has 1 rows, but 30 columns. So they are 3 different objects, these three different arrays. Okay, yeah. So when you do something like plus, minus, or multiply, the tensor needs to have the same dimension. Okay, so like right here, because ty is just 30, so we have to reshape it as well. So I will reshape it to m/1 as well. Okay, yeah. So now for cos, we can just write something like tz minus ty, then square, right? So torch dot, I think we have a square. Yeah. Then we have to sum it, right? Maybe I can write step by step, so it is easier to understand. So what is the dimension of cos now? What is the dimension of cos now?
Đích nơi tại âm cân
m/1.
Vâng.
Right? And then we can do something like cos is equal to cos dot sum. Or it is equivalent as well, like torch dot sum and then cos. So here it will sum every element in the tensor together into just one single value. Okay, this is what we want, right? Because cos is just one single value, right? And then we can just divide it by m to find the average. So now we have our cos, right? And then we can do the derivatives. So just cos dot backward. Okay, yeah. And after that, we can update the gradient. So we can do something like th is equal to, or like minus alpha multiplied by th dot grad. And we have to, alpha is the learning rate, right? So we have to define alpha. Let's say 0.001, something like this. You see? This is for one iteration, right? So we can do this multiple times in order to do it a lot of iterations. So we can just write a loop here. So let's say for iteration in range like 100. And then we put all of this in the iterations. Okay. And one more thing, because here you can see that for th, here it is not the same as before, because before, when we use pure Python in order to compute the gradient, we will recompute it. But for PyTorch, when we you can see that in the next iteration we do the backward again. So the value of the gradient will be accumulated. ចឹងតម្លៃនៃ gradient ហ្នឹងវាបូកបន្តពី gradient ចាស់ចឹងអាហ្នឹងយើងអត់ចង់បានអញ្ចឹង we don't want that. We want it to be reset. We want the gradient to be reset after each iteration, right? So we can do something like after we update the parameters, we have to reset the gradient. So th dot gradient dot 0, I think. No. We want to reset the value of the gradient of each parameters to be 0 instead. Also, like right here, it should not be related to the building of the computational graph, right? Yeah, okay. ពេលដែលយើង compute cost function អានោះយើង build computational graph ហើយមិនអញ្ចឹង ប៉ុន្តែពេលដែលយើង update យើងដាក់ដែលយើង update parameter អាហ្នឹងវាអត់តាក់ទងជាមួយនឹង computational graph របស់យើងនេះទេត្រូវទេអញ្ចឹងកន្លែងហ្នឹងបើសិនជាយើងអត់មានដាក់អីទេ if you do not do anything you can see that this one will affect the computational graph as well because we try to compute like a new expression related to our parameter th here. So actually when you want to update or when you want to reset the gradient of the parameters in PyTorch, you have to put it in this with torch.no. Okay, something like this. It is equivalent as before this one we can write something like th.require grad is equal to false, and then we do this thing, and then at the end we turn it on again. So th.require grad is equal to true again. It is equivalent to something like this. Or we can just put it inside this with the okay. And I think that is it. So maybe we can try to print out. So here I will try to print out the cost. So before backward, I will try to print out the cost. Again, iteration. Cost is equal to, and it is iter and cost, right? And one more thing, like here you can see cost is a tensor, right? If you want to just print out the value, not the tensor, you can write something like .cost.item. It will return a value, not a tensor anymore, right? Because cost here is just one single value. Even though it is one single value, but it is still a tensor, right? But if you want to print out just the value, you can just write cost.item here. So now let's try to run it. I hope that it works. Okay, yeah. You see? Now this is our cost. After, so what is the problem here? How can we solve this one? The same problem that we encountered yesterday.
Too large.
Yes, the learning rate is too large, right? So let's write something like add a few more zero. Okay, you see, right now the cost is decreasing, right? So it means that our model is learning. Okay, yeah. So yes, so today we have talked a lot about PyTorch and how we can use it in order to build our linear regression model. So yes, so now it is 2:58. We have a few minutes left. Any question? I will share this code to everyone, so you can review it by yourself later.
លោកគ្រូខ្ញុំសង្សួរកន្លែង for iteration នេះខ្ញុំអត់ស្រួលយល់កន្លែងហ្នឹងហេតុនេះមក iteration មួយវាប៉ះពាល់ដល់ cost ចឹងលោកគ្រូ
ពីព្រោះគ្រប់ iteration ទាំងអស់យើងកណនា cost ឡើងវិញ
cost ឡើងវិញប៉ុន្តែហេតុអីបានតម្លៃវាដូរលោកគ្រូព្រោះអត់មានអីដែលធ្វើឲ្យវាអត់មាន
យើងដូរតម្លៃ parameter គឺយើង update វាយើង change តម្លៃ parameter ហើយដើម្បីកណនា cost យើងនឹងប្រើ tz ហើយដើម្បី compute tz យើងនឹងប្រើ th ហើយនេះដល់ពេលចប់មួយ iteration មកយើងដូរតម្លៃ th យ៉ាងហ្នឹងនេះ
អូនៅតនេះលោកគ្រូប៉ុន្តែដំបូងនេះ th យើងនេះ0មែនលោកគ្រូព្រោះលោកគ្រូដំបូង th
របស់យើង0
អញ្ចឹងដល់ពេលដែលយើងរើទៅយើងមក iteration ហ្នឹងវាបាន th ថ្មី
you can try to print out th as well. So if we try to run again, you will see th will change. So at the beginning, it is all 0, and after it will change little bit by little bit, so that it tries to minimize the cost. okay, by using gradient descent. So the value of Th will be changed little by little.
Của toán nó khổ nó khổ.
Yeah. Okay. So that's it. No more question. So I hope that you are now more clear about like the benefits of using libraries such as PyTorch, because you can see that in the for exercise 4.1 we have to define the function in order to compute the gradient by ourselves, right? But here when we use PyTorch, we don't have to do that. So it helps a lot, especially next week we will talk about the classification, and you will see a different type of cost function that is more complex than the mean square error with like a logarithm. So if you try to do the derivative manually, it will be very difficult. That is why we can use PyTorch, and PyTorch will do all the hard work for us. Okay, yeah. So I think it's this time now. If you have still have more questions, you can ask me through Telegram group, through our Telegram group. Okay. Okay. So to summarize, I will upload this one to Microsoft Teams, and also please try to continue. Try to look at the classification part of the lesson by yourself. And we will still use a PyTorch in order to implement it, right? You can, yes, because now you have some background on the linear regression. So for classification, it is just like a modification of the linear regression. Okay, so please try to read the slides, try to understand the lesson in advance, and next week we will we will discuss. We will see together. Okay, and if possible, you can also try to do the exercise. Okay, so I think we can stop for today and see you next week. Okay. Bye bye.
Right, teacher.
Goodbye.